Here is the first problem. There are four particles of equal charge and mass suspended from a common point by strings of length L. Find the side of the square that the spheres will form due to repulsion. So let's make a drawing in this. Suppose we are looking from the sidewards. Then what type of thing we'll see? We'll see that the sphere will experience two forces. One due to charge at here, one due to charge at here, and one due to charge at here. Here the distance is A, assuming A to be the side of the sphere. Here the distance is A. Distances being same, the forces will be equal. Let it be F. And here the distance is root 2 times A. So here the force will be slightly less. It will be F by 2. The root 2 by A, if you square, it will be 2A square, which is half in comparison to this force. And these two forces, if you use Pythagoras theorem, you will see that they are also in the same line at 45-degree angle, having a magnitude root 2F. So net force in this direction is due to repulsion is root 2 plus 1 by 2 F. What is the value of F? Q square by 4 pi epsilon naught A square is the effect. So along the sidewards a tension force will act. Okay, I need a separate pen for this. Suppose let's consider this charge. The tension will act along this direction. Let the same vertical angle be theta. So this is a right angle triangle. This distance is A by root 2. Root 2A divided by 2. A by root 2, this is L. So this will be L square minus A square by 2. Okay. So if you separate the force tension into its component, then you will see that T cos theta will be equals to mg. T sin theta will be equals to F net. T sin theta will wait a second. Okay, consider this angle made by the vector with its tail. It is 90 degree minus theta. So this angle will be T sin theta. So here the force of repulsion will act, F net. So here the force mg will act. Here the force T cos theta will act. Okay, I was correct. So the thing to do here is that you have to eliminate T. So if you divide the two equations, suppose this be equation 1, this be equation 2. 1 divide 2, we get tan theta is equals to mg by q square into root 2 plus 1 by 2 times divided by mg 4 pi epsilon naught A square. So what is the value of tan theta? See this triangle carefully. Tan theta is perpendicular by base. So this is the hypotenuse, which is L. Perpendicular by base will be A by root 2 divided by root over L square minus A square by 2. So A by root 2 divided by root over L square minus A square by 2 is equals to Q square root 2 plus 1 by 2 mg 4 pi epsilon naught A square. So using cross multiplication, the thing is that you have to find out the value of A. This is in homework for you. I leave this. And using the same equations, you will see that okay, let me read out the second question for you. If the charge on each sphere and length of each string is increased by a factor k, what should be the mass of each sphere so as to make the side of the square Ka? So from this equation you can easily find the answer to the first part of the problem. Now for the second part, I suggest you better use this equation. It has taken much space. Let me use the different copy. Okay. If you write in this way, T into cos theta. Cos theta is perpendicular base by hypotenuse. So 2 square minus A square by 2 divided by L equals to mg. Square by 2. Also T into A by root 2 divided by L is equals to Q square divided by 4 pi epsilon naught A square. Similar to F net. So T is equals to Q square divided by 4 pi epsilon naught A square root 2 plus 1 by 2 into L by root 2 L by A. Okay, now equate these two, then you will get that so what we told in the question that Q goes to KQ and length goes to KL. Okay, so what should be the mass of the square? What should M go to so that is what should be, by what factor should M be multiplied to so that A becomes Ka? So in an objective question you can do it orally. In this case, if L becomes KL and A also becomes